It's too long. Yeah, most of the answers you can find like right after the actual questions themselves. So, I mean, immediately after. So, like I said, where am I going here? So, the first chapter of this week is on power supplies, and it kind of starts out with just basics such as how all computer technology uses DC voltage versus AC voltage. So direct current versus alternating current. Alternating current is what comes out of your wall in your house or at school, wherever you plug it in. And the power supply in desktops automatically converts that, but in laptops, the actual brick that is between your laptop and the wall is what converts it. So the actual standard connector that you plug in the back of here is known as IEC 320. Probably won't need to know that, but that's one of the things they had in the book. And then just know that the general range is between 110 and 120 volts. So if it's anywhere in there, it doesn't really matter if it's fluctuating between that range. If it goes over or under, then you're in trouble. Some of the older power supplies have switches on the back, which can increase or decrease the amount of voltage that will be allowed into the PC. Now, if you're in a foreign country, you will need to switch this because the voltage coming out of the outlet may be different. However, here it's universal, fortunately, so you don't have to really check. But newer power supplies don't have the switch because they're smart enough to detect what the voltage is, so you don't have to worry about that with those, but you'll still see plenty of these out there. And then there's just a quick little blurb in the chapter about kind of testing your electrical circuits using multimeters. And it's all you really have to know is that the larger socket is neutral, circular socket is ground, and the smallest one is hot or 115 volts. So then, anything from hot should read 115, and anything from neutral to ground should be 0, and actually that should be the only one that's 0. And if it's anything but that diagram, then there's a problem. So this is just a fun little visual as to operating them. They're all a little different, and some of them are higher levels than others. This is a higher end one. It's kind of like a mid-range, but one of the nicest things is the continuity beeper, which is, they call it beeper. It's more like a tone. And the nicest thing about it is that you take your two probes and you put one end on a contact, and you put it on one end on the other, and all it does is tests whether the circuit has been completed, whether it's close, which is really great to see if there's like a short or if there's anything connecting that shouldn't be connecting. Just a real basic low level. If you have a cheaper one, they don't have that, and you have to rely on knowing what the voltage in that line should be, and like normal resistance levels, it's just a pain in the butt. Go to Radio Shack. They're going out of business. These are on sale. That's where I got mine.
Radio Shack unfolded up, and now there's Sprint stores becoming Sprint line.
Mm-hmm. Yep. So these are just common terms that you'll see on them, as well as anywhere in the electrical world. AC voltage, VAC, it's usually abbreviated as DC voltage, VDC, and then ohms is, they symbolize it as an omega. And then the continuity tester is just the testing if it's complete or not. So this is just a process to test if your outlet is performing the way it should. I kind of briefly went over that in this slide. That's pretty much all this is saying right here. That's really it. Just a little more detail into how to do it and what the actual outlets are officially.
Sorry,
Hello. No problem.
Can I sit either place?
Doesn't matter.
Okay.
Alright. So as I said earlier, the external brick that laptops use converts AC to DC current, just like laptops do internally. So the book kind of makes a quick note that, technically speaking, laptop power supplies aren't manufacturer specific, but generally the ends on them are. But I guess like a scenario could be like if you had a Dell laptop or your friend had a Dell laptop, but you forgot your charger at home, you could theoretically use his charger, but the problem becomes is that you don't know if his laptop requires more or less power than yours. So what you kind of have to watch for is these three things: voltage, amperage, and polarity. So voltage and amperage especially, because if any of those are higher than what your laptop is normally set to handle, it'll fry your laptop, or minimally it'll fry your charging circuit or battery. Very bad things happen. I've had several laptops fry that way. Some nice things about some chargers that are made by manufacturers is that they'll actually build in protection for small surges. But like if you have an electrical storm, it's toast. If you ever have any type of electrical storm, you should just unplug it. Don't rely on your power strip to save you. So if you don't want to put a multimeter in your outlet and test things and remember how to do that, you can just buy one of these cheap $5 testers from Menards. I bet they have them at Ace or True Value. And you literally just plug it in your outlet, and it has a little legend right here. And then you just read which lights are lighting up and read the legend, and it'll tell you exactly what's going on. Very basic, and they work well. There's not many things to go wrong on those, so they usually are they just work. Okay, so sag versus spikes in electricity. As everyone knows, I mean, you've probably never had a year where you didn't have a single day without electricity, where you had a power loss. You wake up and your clock says midnight, and you're like, hold on a minute, this isn't right. So there's actually power sags all the time, but they're so minuscule and so, they're just so small that you don't even see them, and they're so brief that a lot of electronics or applications, even just things like fluorescent lights, they don't care about that small surge because they retain enough energy from what they had before. But if you have really sensitive electronics and you keep having sags or spikes, it might be sensitive against that. So what we need is surge suppressors or UPSs. UPSs can have surge suppressors built into them, and they usually do. So large sags are known as brownouts, and complete power loss is blackouts. Pretty easy. The lights go out and it's black. Something the book really stresses is how you should make sure to buy a good surge suppressor because they're relatively cheap, and the alternative is your really expensive electronics that you work so hard to get it fried, and then you're toast. And then on top of it, you might be a year past when you bought it, you don't have warranty anymore. So now you have to rebuy everything. So you get a $10 device that saves a $500 computer. Seems pretty simple to me. I wouldn't have to think about it. But that's the thing, people see the strips and they all look pretty similar, so this is something that the book kind of emphasizes, is that there's a company called Underwriters Laboratory, UL, and their standard is called UL1449 for 330 volt rating, and basically that's just how much electricity the surge protector can handle before it fails and allows the energy through into your electronics or applications. So it's usually stamped directly onto the power strip, like ingrained in, or they might have a sticker on it at the store. So you just look for that, and that'll tell you if it's capable of doing that. So the amount that surge suppressors can handle is measured in joules, which is a measurement of electrical energy. I don't know the formula off the top of my head, but that's how they measure that. So the more the better in this case. They said look for a minimum of 800, but the guy who actually wrote the book, Mike, says he uses about a 1400 joule surge suppressor just to play it safe. Some surge suppressors even have network and phone lines built into them in case you still use a standard phone line. And you can actually run your phone and network lines through those, and that'll help protect against surges in those too, because to keep in mind, all network wiring is just copper wiring, 8 different wires inside one encapsulated and protected cable. So electricity can pass through that too, and I've seen electrical storms pass through network cables and fry multiple switches as it goes through the wires. So it's very probable that can happen. And in the commercial world, there isn't really anything you can do because everything is just connected through networking wires. It is what it is. So UPS is also known as uninterruptible power supply. It's just a giant battery that you plug all your stuff into, and it takes over the power from your power company whenever there's any change in electricity that would affect the way your applications and electronics would function. So it will automatically switch over. There's many types of UPSs. So there's UPSs that will automatically switch over. There's ones that won't, and you can tell them to only switch over unless you tell them to. There's different form factors. So there's ones that mount on server racks. There's small ones that sit under desks for just like a standard desktop monitor, and they rate them in watts for how much power they can handle, and they'll usually tell you, based upon this much power, this is how long you will last with this UPS. So inside your PC, you'll see these connectors are rather common in almost every PC. They're pretty standard. And you'll see this giant connector. It's really frustrating to unplug and plug in because it's a rather large connector. And that provides the primary power to the motherboard and the components physically on it. With the exception of newer CPUs, which require more power, which they have adapters that plug into a separate port directly on the motherboard, and that provides additional power to the CPU. And most power supplies have those now. You don't always need them, but nowadays they just keep getting more and more powerful, so it's likely you'll need it. but don't worry about it not being there if you're buying a new power supply. So there's 3 main types of power connectors that you'll see. First is a Molex, which is an older connector used for PATA hard drives and PATA optical drives, and I'll get to that PATA SATA thing in a little bit. But the Molex is a 4-pin connector. It has 5 volt, 12 volt, and it might have 3.3 volts as well. Anyway, it's really easy to plug in upside down. Even though they made one of the sides curved, if you push hard enough, you can actually jam it in. And it's not like it's not mirrored with both pins. So if you put it in upside down, it's like plugging hot into ground and ground into hot. So it overloads whatever device and you get that nasty electronic smell. You ever smelled that?
Burning of electronics, yeah.
It's over, give it up, just buy a new one. That's what that smell is. I smelled that with a really good DVD drive. I was like, oh. So the mini connector is 5 and 12 volt, and that'll go to floppy drives. Once again, you'll see these, but you're not really going to use them because it's floppy drives. But I guess they put it in there because you might see it. There's a lot of that. If you haven't caught on to that by now, it's a lot of... You'll probably see this, but it's improbable. So, SATA connectors. These are the primary connectors that are taking over. Definitely know these and Molex. If you know Molex and these, then you're good to go. These are... I'm really not going to say impossible to plug in upside down, but they're literally an L shape, so they only plug in one way. And, unless you modded the connector to flip the other way, it's not going to fit. So, usually they'll provide about 4 connectors natively, but you can always use splitters, which I think is another slide somewhere later. So, this is a connector you'll see. PCIe connector. Generally, these are plugged into graphics cards. They'll have the connector built right into it, and you just plug it in there, and it provides extra power that the PCIe slot can't provide for the powerful graphics card. It's optional because not every graphics card will have it, but the higher-end ones will. So typical hard drives will draw 15 watts of power. Of course, you can't. This is all dependent on how much it's actually being used. So nowadays, you'll buy a 600 to 800 watt power supply. That doesn't mean it's going to use 600 watts every time you turn it on. It'll only use what it's required to use when the electronics are drawing power from it. So it'll constantly draw 5 volts because it provides power to the motherboard and the light on the motherboard. So when you press the button, it powers up. So it's basically waiting for a command, and it has to have power to have some electronics going to wait for that. So it has a constant 5 volts when it's plugged in. But I have a 700 watt at home for my gaming desktop. On average, it uses about 250 watts. So it has to have the potential to handle what the computer could use at 100%, because if it can't, then if you ever reach that, it'll literally just shut off without any, warning or anything. But the older ones used to have like 200 watts. I still have one of those because, I have a couple desktops laying around that don't need 700 watt power supplies. They're not anything special. When you used to have dual cores and single cores, you didn't need anything amazing. But the CPUs are one of the largest power hogs within a PC. Between that and the graphics cards, those take quite a bit of power as well. So every power supply does have standard 4 screws, sometimes 3 screws holding them in, and it literally just slides out in theory. Because I say in theory because with higher end desktops, you'll have a giant heat sink, and the heat sink, of course, is right underneath the power supply. And depending on the way your case is orientated, you may have to take that off first to get it to come out. So you're kind of maneuvering a little bit. More than likely, it'll come straight out. Some of the higher end power supplies are smart enough to actually adjust their own fans to keep the case cooler, which is kind of cool. I haven't actually seen that myself. Many newer cases will have internal temperature monitoring built into the motherboard, and they'll have the capability to automatically adjust fan speed to reach a temperature. So you tell your motherboard, okay, I want my desktop to be this temperature at the hottest, and then you just set the coolest temperature to the coldest you can, and it'll go between that range. So when you tell it, you can either do it that way, or you can say that range, and I want the fans to go at a maximum of 80%. So if you have smaller fans, it's going to be like a jet taking off. So the bigger fan blades that you get, the quieter it will be, and the more air it will physically move. So it'll be more efficient, but you have to have the case to be able to support that. So you actually have to have the mouse. So like this one, this is a smaller 80 millimeter fan, so they're measured in millimeters. Some of the bigger ones are 120 millimeters. Those are a lot quieter. So that's the general connector that you'll see. And it looks a lot like the CPU fan connector and CPU power connector. Just CPU fan, sorry. So there was a myth a while ago that taking your back plates off was better for airflow and it would keep it cooler. But in reality, it actually makes it worse because inside your PC it has literal airflow. So you have the back fan, which is near the bottom of the case, pulling in cold air. And then as heat rises from the case getting hotter, the case fan in the back pulls all the hot air out. So if you have cold air coming in and cold air coming in, then you have all this air going in random directions and you don't get any airflow. That it becomes very inefficient, is what I'm getting at. So put all the slots in just to keep everything flowing fluidly. So like I said, if you have smaller fans, it's going to be like a jet taking off if you're trying to keep it really cool. 3-pin connectors is very common. You'll see 4-pin connectors more recently, and that will that gives the motherboard extra capability with control over the speed of the fan. The manufacturers will advertise the fans themselves as like quieter fans, and they rate them by decibel, but I never really check the actual decibel rating. I'll see if they call it a quiet fan, and then I'll buy a large fan. Basically, I'll buy the largest fan that my case can fit, because it makes it a lot quieter just for that alone, even if they don't advertise it as quiet. So these are kind of nice too. It's just a little piece of plastic, and you plug your power supply cable into this device, and then all the lights light up, symbolizing that it's providing the correct amount of power on the pins that it's supposed to. And then, right in the middle, it has like instructions on what it should look like if it's operating properly, and then usually on the back they're like, if this happens, then this is what's wrong with it. But usually, if anything is wrong with it, then you throw it away because you should never open a power supply. They have giant capacitors like this big, and it's very dangerous. There's pretty much nothing you can do if it breaks. And it's highly advised to stay away from trying to modify power supplies or do anything like that because they are very dangerous. So power supplies are always intermittent failures, and it makes it very difficult to diagnose a PC because usually you turn on your PC, and all the fans spool up, including the power supply, but it might not be, fully providing the required amount of power that it needs to function correctly. So you'll kind of hear things like, sometimes my screen goes blank and then it comes back on after I reboot. So that might be a sign that the power supply dips down and loses power on those certain connectors. So it's just kind of weird, random things like that. Usually the power supply is one of the last things to check when you're diagnosing a PC because it's a pretty unlikely component to just fail randomly. Usually it kind of happens over time. And it's usually one of those issues where people are like, yeah, it's kind of been going on for a while, but I can deal with it. Do something like that. So, yeah, they really emphasize never ever opening it. So, they have built-in internal fuses inside them, and if you've ever heard a fuse go off, it's just like a snap kind of pop noise. Just throw it away. It's not worth it. They're not cheap, but it's not worth trying to open it up and possibly hurting yourself. And they recommend having fire extinguishers, but I've never had any components light on fire, although I would deserve it. These are kind of nice. Modular power supplies. I got one of these a little while ago, and it's just removable cables. So instead of the older style, where they include every cable you need, what they do with modular is they give you the power supply, and the only cable that's actually attached to the power supply is the one that goes into the motherboard. All the other ones come as removable cables in individually wrapped bags, and they only fit in specific slots so that you can't accidentally plug it into a slot that has a different level of power. And it's really nice because it keeps your case really neat, and it increases airflow as well because you have fewer cables. And it's
a big clump of cables.
yeah, and then you have a zip tie.
Yeah.
Just less frustrating as well because you know what you need and you don't have all that stuff in the way while you're trying to install it. So hard drive technologies. This was a long chapter. So the older hard drives before SSDs were beginning to become popular had spinning platters on them, and depending on the amount of space that was included, would have more and more platters, and they would get thicker and thicker. So you'll see really high capacity drives be thicker than lower capacity drives. So as time went on, they increased the speed at which the drives were capable of spinning, and they spin at what's known as revolutions per minute, or RPMs. If you ever see a 5400 drive, just kind of get rid of it because it's going to be really slow. They have a yeah, it's slow. I'll deal with 7200 if I have to, but I've never gotten a 15,000 because they're really expensive. You're just better off getting an SSD. They warn that they create a lot of heat, but I don't see like an extreme amount of heat. I mean, it's a little warmer, but what do I know? So SSDs, completely separate idea from original hard drives, zero moving parts. It's basically like a high capacity flash drive is what you can think of it, except much, much faster. So this is the literal definition, the second bullet point, and it's literally just memory chips. That's all you really need to know. They're a lot faster, they're more expensive right now, but they've been getting cheaper, just as hard drives did. So definitely recommend getting one of these. They're also becoming more reliable. They used to have problems where they would fail really quickly. They're better now. So the most common is really 2.5 inch or I haven't seen 3.5 inch. It's really 2.5 inch that you'll mostly see them in. Traditional hard drives were 3.5 inch in desktops and 2.5 inch in laptops. Even spinning platters were. But so far, I've only seen SSDs as 2.5 inch. So, so they reference integrated electronics, also known as IDE. So it's a hard drive with a built-in controller. So it emphasizes that all drives are technically IDE, but we only really reference to original platter drives as IDE. No one does, but the book does. So ATA drives, Advanced Technology Attachment, also referred to as IDE drives. And then other technologies, SCSI, and these are all elaborated on, so I'm not summarizing them here. Small computer system interface. They're mostly commercially used with like backup systems or SANs. You won't really see these residentially. They're a lot less common. PATA drives are the drives that have those ribbon cables. Older, less common. You'll see them every once in a while, but for the most part, it's SATA now. If you don't have SATA, you should get SATA. It's much faster, because in reality, the hard drive is the primary restriction to speed on your PC. And what's the use of having a fast hard drive if you don't have a fast cable to allow that data to transfer over? So that's what a PATA drive looks like. It's that connection. Which was slightly annoying as well if you bent a pin. You're like, ah, gosh darn it, and then you have to try to get it back without breaking the pin. And okay, now they have, this is where it gets complicated. They have like all of these ATA standards. It's 1 through 7. And the biggest thing is that as it goes up, they get rid of things that don't make sense and add things that are much better. So ETA, they used jumpers because they had IDE cables that you could connect to hard drives or like a hard drive and a DVD drive to, and you had to have these jumpers to signify which device was the master, which was the slave. So generally the hard drive would be the master and then the DVD drive would be the slave. So like if you had 2 hard drives, let's say one had Linux on it, one had Windows on it, and you had a Linux bootloader, like Grub is a good example of that. And then what you could do is have your PC, by default, boot to that master Linux drive, and then that bootloader on your Linux drive could point to either Windows or Linux. So it was kind of a pain when you were putting the actual machine together, because you had to worry about putting those jumpers in the right place. The nice thing, however, on the drives themselves, they usually had a key telling you which position was master or slave. So that was nice. So PIO and DMA modes. Basically, they went from really horribly slow to acceptable over the years. So PIO, also known as Programmed Input-Output Address, and Direct Memory Mode. PIO is where the CPU talks directly to the hard drive via the BIOS to receive and send data. So as you can see, it's very slow early on. So as the ATA revisions are being developed, it goes higher and higher. So they started out with what they call single word DMA. So it's the oldest kind of DMA. And obviously you can see it's very slow. You know, modern USB flash drives are, you can do like 80 meg on average, depending on the machine, 40 meg. So ATA2, developed in 1990, referred to as EIDE, but it's really just a marketing term made coined by Western Digital. All it is saying is, this is IDE, but it's a little better. That's it. So EIDE allowed for larger capacities and non-hard drive storage devices. What they mean by that is things like zip drives, DVD drives, floppy drives, etc. Whatever else you can think of. Now, there were restrictions back then where the BIOS would only allow you to have a drive of 504 megabytes. So what they did is they created something known as logical block addressing, known as LBA. And all it is it's a little piece of software built into the hard drive that lies to the BIOS and tells it that it's 504 megabytes. But it's smart enough where the operating system recognizes it as a larger size. So this picture symbolizes like the way a hard drive would look if you separated it out into sections, or sectors they refer to them as. So that's the right one. The left one symbolizes a hard drive with its platters. But as you can see, this hard drive has too many platters. It goes over the actual physical limit of the box. So they would have to make the hard drive bigger to fit that amount of platters in it. So let's see, what was I doing here? So the physical geometry is the literal configuration of the disk, and then there was a logical geometry, which is what the drive told the BIOS it was. So the logical geometry is what allowed manufacturers to make larger drives. So here's two examples of how it ended up lying to the BIOS essentially. So the bottom one, 16,384 cylinders, and then it just told the BIOS it had 1,024 because it only recognized that. So yeah. ATA-PI. So Advanced Technology Attachment Packet Interface. Allow non-hard drive devices such as CD-ROM devices to connect via ATA controllers. It's just using the same cable. The controller is built into the motherboard. No confusion there. So ATA2 allowed for a second controller, so they would add a second port on the motherboard. So you could plug in 4 drives instead of only 2. So if you had like a DVD drive and then you wanted to have 2 hard drives, you could do that. Or if you had a DVD drive and 3 other hard drives, you could do that too. Assuming you could make your cables reach, because they were a maximum of, it's in one of these slides down here, but it's, you don't really get this until you do it, but like ATA cables are never long enough. They're always like a couple inches short, just like so close. Maybe if I stretch it, it'll get there. Well, that's solved with SATA, but that's later. So multi-word DMA is just a fancy way of saying it's a new protocol built upon single word. It's just faster. That's all it is. ATA3 included a new feature known as Smart. You don't actually need to know what these individual, real world, you won't need to know what these stand for. The exam you will. And it's one of the few that you actually need a period for because each letter actually stands for a full word. So all you need to know is that Smart just tests to see if the drive is functioning correctly physically and on a sector level. So every manufacturer has a utility of some kind, it's usually bootable. Otherwise, they might have a Windows utility that you run, and that'll test your internal drive. Those are actually pretty nice, but a lot of the times they include a whole lot of jargon and gibberish in there that nobody ever understands. You're like, yay, green check marks. It's good. I don't know what it means, but it's good. So I guess you just trust the manufacturers that they're not lying to us. So there is a new DMA mode in ATA4, which they call Ultra DMA. I mean, you think about how far it's progressed. We went from like 3.3 meg to 33.3, so it's pretty huge. I don't know the time frame from ATA 1 to ATA 4, but I think 3 was in 1990, it said, or 2? I don't remember. Yeah, something like that. It was a while ago. All of these are a while ago. I don't really know why they think it's relevant that we know how fast old technology works, but they do. So ATA 1 actually allowed for 137 gig drives, but because whoever invented the BIOS thought that people were only going to use 504 megs, so kind of, yeah, killjoys for everyone. So the super slow 3.3 meg technology allowed for something really big. So Phoenix Technologies, the people that developed BIOS, came up with what's known as int13. It's called as interrupt 13, which broke the 8.4 gig barrier by completely ignoring CHS values altogether. So it can support 137 gig. So yay! Their new BIOS allowed for the largest hard drives that ATA is currently supporting, which is awesome. So then, over time, Ultra DMA came up with newer protocols, 66.6, and then ATA 5 also needed a new cable with more wires to support the speed. You won't see anything beneath 5 or 6 anymore as far as the cable size goes. So this is just kind of a funny tidbit, but this is still a long time ago, and 144 petabytes were still not even there. Big drive. They really couldn't have come up with something any less creative. So T13 just made something really, just picked the complete opposite and went super technical, just called it ATA 6. So fortunately, it finally got to 100 megabytes per second and called it ATA 5. And uses the same cable as 5. Sorry, read it wrong. So SATA comes, and then everything in ATA is completely forgotten and it doesn't matter anymore. Well, wrong. But if you know ATA 6, you're fine. So ATA 6 and SATA, I would probably know those. The other ones, you might want to know that ATA 1 was capable of the largest speed, but BIOS couldn't handle it. Honestly, the 3, 4, and 2 probably not important, but know about the int13. I just put it in there because the book had a giant chapter on it, so apparently they thought it was really important. SATA is apparently hot swappable, but if you really think about it, why would you want to do that? If you're in the middle of writing data, why would you want to unplug your hard drive? It's kind of a silly idea to begin with. So there it is. ATA's ribbon cable limit was 18 inches, and you never really saw them at 18 inches. It was just never enough. You see 18 inches, it sounds like a lot, but it's really not. But now, I think it's something like, let me see, trying to find the SATA length that it supports. anyway, it's enough to reach across the entire, case itself. So because of how small they are, you get more airflow once again. So if you have a modular and you have SATA cables in there, you get lots more. So 1 meter cables, which you'll never have ones that big because you'll have problems with cables getting into fans and all kinds of problems. No more master-slave stuff either, so that's really great. And no limit about how many drives aside from what your physical case can hold and how many slots are on your motherboard. Of course, standard desktop, you're probably not going to have more than 2. But if you have a server, you're probably going to have 4 or more, depending on what kind of server it is.
Did you touch on the cable select for the master slave?
Touch on what?
Cable select.
No.
The middle connector always being.
No. No, they didn't mention it. I think they should have, though, now that you say that. Yeah. Who knows? Maybe they will include it. Little background, cable select is kind of a nice thing that they had. Where it's been a while. Maybe you could explain it better as far as practical application.
Say you had two drives or maybe the one drive on the CD-ROM drive. Instead of messing around with the jumpers to say this one's going to be the primary and the secondary, cable select would automatically assume that you hear the cable is the primary. The one in the middle would be the secondary.
Oh, wow.
Which everyone eventually ended up using anyway because they got sick of moving jumpers around.
Well, but when you touch on the cables, you need this much.
Yeah, because what they do is they give you this much between the middle and the part that goes to the motherboard, right? So you have that much cable to get from the motherboard, which is here, to your drive, which is here. Okay? Now you have this much cable to get from your hard drive, which is here, to your DVD drive, which is up here. So you're like playing the magician, trying to move your cable around. You're like, maybe I can twist it this way. No more of that. So current maximum speeds, 6 gigabytes per second, which is pretty amazing, but once again, it's always theoretical speeds because you're depending on the drives actually being able to handle that and the motherboards, Northbridge being able to handle that. Now here's something that kind of puzzles me. This is a board which I've literally never seen ever. And apparently, you plug it into a PATA port, and then it has a plug on the other side for SATA, which is kind of handy if you need it, but...
You have a portable drive, to use it. The older ones had those built in. A lot of them had IDE drives in them. And they just
the externals, you mean?
the external drives.
Like the USB things?
Yeah.
Yeah. That's
So
right.
the earlier ones had those little converters built into the housing. You didn't really know that you were running on a slower IDE.
You're like... Yeah, that's always a disappointment. You open it up, you're like, hey, that's not what I bought. Yes, it is. So, I've never seen anyone using it like that. No. Well, nowadays, you can buy little adapters that get enough power from the USB connector to power the drive, and then they just plug right in, and you can plug it in like a USB drive. So you get a little reduced speed because you're running off the power of the USB to run the drive. However, you have a drive connected with one simple cable, so usually you're just recovering a file or two if you're doing something like that anyway. So AHCI is actually required to get some of the SATA features such as hot swapping and native command queuing working. Generally, this is enabled by default. Another mode is called IDE, and that just refers to the original mode. It's just not this. It's that or this, pretty much. I've done this once. You don't enable it after you install because you'll immediately get a blue screen. You're like, hey, that's not cool, but it's just the way it is. So eSATA, it's a SATA connection but externally. You just plug in from your external SATA device to this connector on the outside of your laptop. Most newer laptops have it now. I haven't really seen anyone that's used it. Where I have seen it, however, is with backup devices in the commercial environment. They'll take a 1U backup device and then they'll put a external drive on top of it, literally, just like a drive you would buy at Best Buy or whatever. Just set it on top, plug in, a 1-foot cable or whatever, and back up to it that way. Works fine. I mean, you don't really need anything special. So that's an option. I don't know if it's faster than like USB 3. They don't really specify speed for eSATA in the book, but I'm assuming because it's going through.
It's supposed to run at the same speed.
So same speed. Okay. So this is pronounced SCSI, and they go into SCSI a lot, and I breeze over a lot of what they included in there because there was just so much raw content, and some of it was a little redundant, to say the least. So if you have multiple SCSI devices, you connect them together using what's known as a chain, so SCSI chain. Each SCSI device gets an ID assigned to it, usually just some digit number. Depending on how many devices, it might just be 1, 2, 3, 4. So they look like this. So you have a host adapter, which is where all of the devices end up connecting to, and the host adapter is in some fashion plugged directly into your machine, usually like a expansion PCI slot. Once again, you don't really see these residentially, but commercially, as far as backbone, you will. And a lot of the times they're built in. You don't really touch them. The manufacturer puts them in. And then get into termination, which is just not fun. But I don't know why they didn't just design the protocol to not have this problem to begin with, but I don't know. Apparently, it's good enough that people still use it today. So, you just have a little device that terminates it. I've also seen it where people have a cable. It's just a little dongle. They literally just plug it into the end and that terminates it. I mean, it's not like a physical giant device or anything.
Many years ago, I had a scanner, it's this living part, and you had the input onto the scanner and the output, we just had one sort of button.
Sure. Yeah.
You plug it out and tune up something else if you want.
Which is kind of useful. I mean, if they have that with USB, that would be kind of useful. It's almost like building a USB hub into every device if you think about it. You're basically just sharing the connection. So they go into RAID real briefly. I kind of think they try to make it a little more complicated than it needs to be. So RAID 1 is just taking 2 drives and making them completely identical. They will keep exact copies of the data, but it is a slower read-write speed. So if you lose one of the drives, it continues to run without interruption. But obviously you lose the second drive and it doesn't run anymore. Disk striping, 2 or more non-redundant drives. So they they basically increase the amount of space that you have. So if you have two 100 gig drives and you use RAID 0, you'll have 200 gigs of space. But if you lose any drive, you lose all your data. Sometimes this is used with gaming. I don't see RAID 1 used a whole lot, but every once in a while I'll see it in like a desktop. You know, someone will have two drives and they'll mirror their data drive. I usually have a separate drive for data and one for my OS, so if my OS crashes, I still have all my data. RAID 5 and 6 are used commercially, and this requires at least 3 drives, and you can lose 1 drive, but if you lose 2 drives, then you lose your data. So if you lose 1 data, then you're in a critical state, and you need to replace that as soon as you can. So once you replace it, it does what's known as resilvering, and basically what it's doing is taking the data from the other drives, copying it back over, and once that's fully copied, then you're back in a good state. RAID 6 is the same thing as RAID 5, but it requires at least 5 drives, and 2 drives can be lost before everything is lost. So that's kind of nice. RAID 5 is the most common right now. Alright, I just thought this would be easier to explain than write out. Hardware RAID is just having a physical device in your PC, whether it's a controller built into your motherboard, or if it's an expansion device built into, or like an expansion device that you put in a PCI slot. And all it does is connects to your drives and mirrors them, or makes RAID 0. And that's hardware RAID. That's the best kind of RAID that you could have, but then you have to buy that other device. And it's also more efficient because you don't have to rely on the OS. Software RAID is you can do that within Windows, Linux, probably Mac as well, I would imagine, if you really wanted to. But because you're not supposed to mod Macintoshes, they probably don't have it. So in Windows, you just have 2 drives, and in disk management, you can easily set it up. They don't really make an easy wizard that says, I want to do RAID. How do I do it? They have plenty of articles out there, though. When I say they, I mean Microsoft and communities out there that kind of show you how to do it. In addition, many, many videos. But software is the easiest and most straightforward. If you really have important data, hardware is the way to go. That check took me a long time to make. So MBR, it's just a tiny bit of data on the drive, which is known as the master boot record. So it contains the partition table and the sizes of each partition. So the MBR is limited to 4 primary partitions. I forgot to put that in there. It's 4 primary total partitions. So you can have what's known as logical partitions, but you can't install operating systems on logical partitions. So inside logical partitions, you can create additional partitions. It's a really large number of how many partitions you can create inside logical, but the 4 primary really is irritating, because if you want to have more than 2 operating systems, which is kind of nice, you can't really use MBR because most operating systems have like 2 partitions per. So like Windows has a primary OS, and then you have a reserved, and then you have an EFI. So they actually have 3 partitions for modern Windows. So already you've knocked out those partitions, which is just frustrating. But fortunately, if you have 64-bit Windows, you can use what's known as GPT, which eliminates those size restrictions and partition amount sizes. So you could have way more than 4 primary partitions, and a partition size limit is really crazy. So 2.2 terabytes to zettabytes, and they didn't say the amount that it's limited to because the number is so large we'll never reach it in this decade, century, I should even say, because it's ridiculous. But a zettabyte is 1,000,000 terabytes. I mean, just one zettabyte alone. So also, GPT allows LBA right out of the box, so no need to lie to the CMOS anymore. Right? Quick break. 10 minutes.
Something.
Remember Gage or somebody talking about they'll never need have a need for anything over 500 megabytes? Or-
Yeah. Yeah. Sure showed him. You'll never need anything. Yeah.
Actually, maybe rewrote Windows instead of adding to it.
Yes, we will. Let me figure out why it's lagging. Where's my mouse? There it is. Oh no. Streaming program is frozen. Oh, that stuff. Okay, there we go. Got it. So, from Windows ME and below, FDisk was a common program to format drives. The modern one is disk management in the GUI and diskpart in the command file. For Linux, you can still use FDisk and gdisk. Gdisk is for GPT only, and FDisk is for MBR disks only. And it'll specifically tell you if you try to use it on a disk that's formatted GPT or MBR, or vice versa. So at least you can't screw it up in that fashion. So formatting doesn't just create a file system, it actually creates the root directory as well. And you can't do anything without first formatting it, except drill through it with a drill or hammer it if it failed. So these are the 4 most common file systems that have been used over the years. So FAT used to be one of the most common ones, and that was a sector limit of 512 bytes of data. And this is actually really inefficient, because if you had data files that were under 512 bytes, then the next file would be written to the next sector instead of filling up that space in the previous sector. So you'd have tons of open gaps. Very, very wasteful. So FAT16 is the same as FAT, however it added a bad sector marker, which is basically just Windows saying, hey, this sector's bad, don't read or write from it, because it won't write or read efficiently. And in current times, this can also be done by formatting the drive without using quick formatting, and if you defrag your drive, as long as it's not an SSD, it'll do the same thing. Now FAT32 is the, it's not the most current USB formatting used, however it is the most common. So FAT16 was limited to 2 gigs with 32 kilobyte clusters, and FAT32 uses 4 kilobyte. So instead of having a 512 byte sector sizes, you know, with 4 kilobyte clusters, which allow you to use the space much more efficiently, and you don't have these open gaps all over the place. One of the biggest things with NTFS is security, how much control you can have over file permissions. So one of the things you have to keep in mind when you're working with FAT and NTFS is if you take a file and you put permissions on it, let's just say I want full access, but I want to give other members in my study group only read access. If I take that file and I copy it, you know, to a file share, and one of you takes that, copies it down to your FAT32 USB drive, all of those permissions get stripped when it gets copied to FAT32. So you can actually completely bypass all of those if you do that. which is kind of awesome. But not for the people who are trying to protect, confidential data. So you also get redundancy in because you never use FAT with, RAID. It's always NTFS, or you're using REFS, which is not included in this book, so I'm assuming it's not in the exam. So compression, taking big data and smooshing it together, making it smaller. Encryption, making data more secure. Disk quotas, there's actually slides that go into each of this, but disk quotas are limiting how much of the drive can be filled. And you can do it by percentage, and I think you can also do it by like physical megabyte or gigabyte size. Okay, so they have a better file allocation table as opposed to the original FAT32. So as I said, they use ACLs and ACEs, and make sure you know that ACLs are contained within ACEs, and there's a chapter later on which goes into depth, more depth about this specifically. Just compressing things, and they're displayed in blue, which is kind of nice. Some programs get kind of picky with compressed files versus non-compressed files, so you can distinguish those by seeing the color of the file. So the encryption that NTF uses is called EFS. Despite its name of encrypting file system, it's not a separate file system. It's just a module that's a part of NTFS. And I said, just allows administrators to limit how much of the hard drive can be filled up. You can even do per user basis. So if I want to make sure that I can allocate as much as I want, I can fill it all the way to the top. But I want to make sure people in study group can only fill 10% of it or whatever. So you can't be dumping all your data onto it, it's using it as a backup or whatever. I haven't seen this been used, but it's a good idea in theory. FAT64. This is also known as XFAT, which is in the next slide as well. And it bypasses the limits that FAT32 has of having a 2 terabyte drive limit and the individual file size limit of 4 gigs. XFAT is generally recommended for larger external drives, usually not USB drives because they're not really giant. I mean, you can see like 64 gig drives, but you don't get anything like giant, like 4 terabyte USB drives or anything like that. Theoretical partition limit of 64 zettabytes. So you have, theoretical limits of the amount of partitions with GPT, and then you have theoretical limits of 64 zettabytes per partition. But Microsoft recommends 512 terabytes maximum per partition. So we should be okay for a while. But hey, you never know. Look what Bill Gates said about the limits of size, what we'll ever need. So this is just a formatting page on Windows XP install. Probably seen this several times. Kind of just keep hitting enter because you don't really care about it, which is fine. They don't really have a name for partitioning that's not quick partitioning, so I just refer to it as regular partitioning. Just so you know, that's not the official term for it. They don't really have one. It's either quick or it's not. So normal partitioning checks all the sectors and flags them down as this sector's bad, this sector's bad. Quick partitioning skips that, which is normally fine. But if you have an issue where data is kind of writing weird, usually you'll just reformat without quick formatting in place. And then, just like the XP page, this is how you go into formatting in Windows 7. And usually you delete the partitions first. You delete all of them. Just start fresh. And then you can literally get Next and it'll automatically do them. Or if you want to like separate out data partition in OS, you can do that using the new button, and a box pops up asking you how big you want it, so on. That's all I have. That was a lot of information.
Tuesday nights we're starting at 6:30, right? Or do we start at 6?
6.
6? Okay, I'm safe.
It's okay.
No, 6:30.
6. I can change it to 6:30. It's fine.
That's when we started.
Okay, that's fine.
No, I didn't.
I mean, that's when we started, but it was supposed to be 6.
Was it?
Oh,
Because
really?
she wrote 6:30.
Oh, she did.
Yes.
It doesn't matter.
So
We'll start at 6:30.
Okay.
Okay. Okay. Yeah. 6:30. I waited.
I thought you were sitting here early.
Well, I was because I had a class that ended at 5. So I just came in here, and kind of got ready, finished some stuff I had laying around, and so it wasn't really a problem.